Students, today we will discuss the chapter 2, that is inequalities, simple and compound inequalities, inequations, etc. What do you mean by inequations? When something left side is greater than the right side or less than. So here two quantities may have between them three relations, one of equality and two of inequality. If they are unequal, then one of those quantities must be either greater or less than the other. So in between the two quantities, like that, suppose there are two quantities A and B, the three things arises here: either A equal to B, or A greater than B, that is A is greater than B, or A is less than B, there is a symbol A less than B. So A equal to B, A greater than B, or A less than B. So if in between A and B there is an equal sign, greater than sign, or less than sign, so this is called equality, and these two are called inequality. So we will discuss something of inequalities. Then what do you mean by x greater than 5? What do you mean by x greater than 5? If x is an integer, then we say that x is any integer from 6 to infinity. The solution of the equation is infinite. It gives a set of values of x, values for x. Here, if x is an integer, then we say that x is any integer from 6 to infinity. Because x is greater than 5, the solution of the equation is infinite. It gives a set of values for x. What do you mean by 5 less than x less than 7? There is a value of x is lies between 5 and 7. In between 5 and 7, if these are integers, then only 6 is there. In between 5 and 7, only 6 is there. Here the values of x, which is integer, then 5 or less than 7 is an integer 6. In this case, the solution gives a single value. It must be noted that there are two simple inequations, x greater than 5 and x less than 7, combined together to form a compound inequation. So what is called compound inequation? This is called compound equation because the two simple equation, one is x greater than 5, another is x less than 5. With these two simple inequation combined together to get an compound inequation. What is this? 5 less than x less than 7 is called compound inequation. Some more compound inequations are: x greater than equal to 5 means either x greater than 5 or x equal to 5. X less than equal to 3 means x less than 3 or x equal to 3. 2 less than x less than 5 means x greater than 2 and x less than 5. X less than equal to 4 means x is not less than 4, x not less than 4, that is x equal to 4 or x greater than 4. These are simple inequations or compound inequations. Some compound inequations are there. These are the two it is called compound. X greater than equal to 5 means there are two simple inequations. One is x greater than 5 or x equal to 5. So therefore this is called compound inequation. The simple inequation, the combined inequation of two simple inequation, we get a compound inequation, and others are there. Then the next fact is that some properties of simple inequations. If a greater than b, then a plus x greater than b plus x. We can add any positive number x. We can add any positive number x to both sides of the inequality. We can add any two positive number x to both sides of the inequality. We can subtract any positive number x to both sides of the inequality, then this symbol greater than will be same. We can divide both sides by a positive number x, then this symbol greater than will be remain same. If we multiply both sides by a positive number x, then the a into x is greater than b into x, the sign will be remain same. But if a greater than b and x is a negative integer, if x is a negative multiplier, that is, if we multiply both sides by a negative number x, then the inequality sign is changed. If a greater than b, if we multiply both sides by a negative number, suppose negative number is x is a negative integer or x is a negative multiplier, then this greater than sign will be changed to less than sign. This greater than sign will be changed to less than sign. Thus if a greater than b implies a into x is less than b into x, because x is a negative, x is negative, Again, if a greater than b, then a by x is also less than, say there is greater than symbol, this symbol will be changed to less than symbol, b by x, if x is a negative number. Then we do some problems of that chapter. It is one. First problem is example 1. If twice x plus 11 greater than x plus 15, find the value of x. Find the value of x. Given that twice x plus 11 greater than x plus 15, everybody please see these numbers here. Twice x and x are variables, 11 and 15 are constants. So first of all, between these two constants 11 and 15, the 11 is smaller than 15, therefore we subtract 11 from both sides. We can subtract 11 from both sides. We subtract the smallest number 11 to both sides. Then what happened? This 11 cancel, left side is twice x remain, this greater than symbol is remain. X plus 15 minus 11 is 4, x plus 4. So again, out of this twice x and x, we can subtract out of these two numbers, x is smaller than twice x, we subtract from both sides x. So twice x minus x is greater than x plus 4 minus x. Therefore in the left side, twice x minus x become x, and here x is cancelled, it is 4. So x is greater than 4. The required value of x is any number greater than 4. So it is a fact. Okay, then example 2, it is again the solve 3x plus 15 less than 5x plus 11. So out of 3x plus 15 and 5x plus 11, 15 and 11 are constant numbers. Out of 15 and 11, the 11 is smaller than 15, then therefore we subtract 11 from both sides. Left side 11 subtract, right side 11 subtract, then right side 11 cancel, right side will be 5x remain. Here it is 3x plus 15 minus 11 is 4. Then out of this 3x and 5x, these are two like terms, we subtract thrice x, because thrice x is less than 5x. So thrice x from both sides, thrice x subtract, then thrice x subtract. Then left side thrice x is cancelled, left side is 4 remains. Here it is twice x. Then we can divide both side by 2, because we have to find out the value of x only. Then we can divide the both side by the coefficient of x, that is 2. Then 4 by 2 less than twice x by 2, that is 2 less than x, or x greater than 2. The required value of x is any number greater than 2. Therefore the required value of x is any number greater than 2. So these are the problems. And example 3 is a problem. A milkman purchased 9 cows when he had twice as many cows as he had at the beginning. With the addition of the newly purchased cows, the number was found to be more than 3 times the original number of cows. What is the highest possible original number of cows? So please read the question carefully. We have to find out what is the highest possible original number of cows. So a milkman purchased 9 cows when he had twice as many cows as he had at the beginning. So suppose at the beginning the milkman had x cows. Then twice as many, that is the equation will be as that what? Let us suppose that the milkman had x number of cows at first. Then according to the question, it is twice x plus 9. Twice x plus 9 is greater than thrice x. Then we can solve it. Twice x plus 9, there is twice the original number, and add the 9 new cows, which will be greater than the 3 times the original number. So out of this inequation, twice x and thrice x, the twice x and thrice x, twice x is smaller than thrice x, we subtract twice x from both sides. Then it is twice x, twice to cancel, 9 will be there, and twice x, thrice x minus twice x is there, and then we can change it is x less than 9. Highest possible original number of cows is 9. Then there is exercise 3. Exercise 3, if a equal to b plus k, where b and k are positive but k is negative, then prove that a less than b. So given a equal to b plus k, as k is negative, there is k is subtracted from right side. K is subtracted from right side, and it becomes equation a equal to b plus k. B is greater than a, then b is greater than k, because a equal to some b plus something, therefore automatically b is greater than a, or a less than b. Then number 2, write the following with the help of algebraic symbols. A is the positive number. if a is a positive number, we can express it as a greater than 0. A is a negative number, we can express it as a less than 0. A is equal to 0 or a positive number, a equal to 0 or a greater than 0, that is a greater than equal to 0. A is equal to 0 or a negative number, that is a equal to 0 or a less than 0, that is a less than equal to 0, and so on. Then the next is what? Number 5. A is any number between 5 and 8. A 5 less than a less than 8. State from each of the following relations whether x is a positive or negative. So we can solve it. X plus 1 greater than 1, we can solve it. We subtract 1 from both sides, then it is x greater than 0, therefore x is positive number. Similarly here it is x plus 2 greater than 3, we can subtract 2 out of 2 and 3, subtract 2 from both sides, we get x greater than 1, so x is positive. Then similarly we can show all that things which are positive or negative in the similar way. Then it is, we discussed this number is 4. Twice x plus 3 greater than thrice x plus 3, then we subtract 3 from both sides, then it is twice x greater than thrice x, we subtract twice x from both sides, because out of twice x and thrice x, twice is smaller, then it is 0 less than x or x greater than x less than 0 greater than x or x less than 0, so x is negative. And then it is solved. So I am again discuss this solving fact, which is that 7x plus 23 greater than twice x plus 38. So here one is the variable, another is constant. In the right side one is variable, another is constant. So out of this constant term 23 and 38, 23 is smaller than 38, we subtract 23 from both sides. So 7x plus 23 minus 23 equal to twice x plus 38 minus 23. We can subtract 23 from both sides. On left side 7x remains, right side twice x plus 15. Then out of 7x and twice x will be subtracted from both sides. 7x minus twice x and then twice x. Okay, then twice x will be cancelled, right side 15 remains, 7x minus twice x is 5x. So now we can divide both sides by 5, there is a coefficient of x, we can divide both sides by 5, greater than symbol will remain, then x greater than 3. So this is the answer, x greater than 3. So in this way all the problems are done. 5, 6, 7, all the problems are same, the same procedure. Now we discuss the problem number 8 here. 3 into x plus 11 less than 6x plus 15. Then first of all we multiply 3 into x plus 11, that is thrice x plus 33. 3 into x thrice x plus 3 into 11 33 less than 6x plus 15. Then out of 33 and 15 we subtract 15 from both sides, minus 15. Then it is 33 minus 15 is 18. Then right side 15 will be cancelled, 6x remains. Then out of 3x and 6x we subtract 3x, because 3x is less than 6x. Then subtract 3x from both sides. Left side 18 remains less than thrice x, and we can divide by 3, that is 18 by 6 less than x. 6 less than x means x greater than 6. So this implies sign will be there, because this inequality symbol is there, less than. So left hand side and right hand side both will be here. So in this way question number 9 will be done here. Question number 10, 11, 12, 13, 14. Please do all that up to question number 15. Thank you.